Hi, today we're going to how we can able to solve exponential. So one thing that we have to know about exponent and when it comes to equations is that when we have the same base, then we can able to equate the exponent or the power. So here b to the power m is equals to b to the power n. Therefore, we can say that m is equals to n. It's going to help us as we're moving forward to solve this exponential equation. And this is just to let you know as we are solving the exponential equations, a lot of stuff is going to pop up. Linear equation is going to pop up. A radical or surd equation is going to pop up. Quadratic is going to pop up. It's also a review as you want to learn maybe more about linear, quadratic, and radical and all that kind of stuff. And system is also going to pop up too. Let's start. So we have been given 27 is equals to 9 to the power 2x minus 1. We need to get the same base, so we will try to see. So what comes into our mind? Oh, 9, 3. So let's try to break all of them into threes and see how we can come out with. So 27 can be written as 3 times 3 times 3. And the 9 can also be broken down as 3 times 3. But remember, it was raised to the power this. Just cover it with a parenthesis. 3, 3, 3. They have power 1 here, power 1 here. We don't write it, so we will have 3 of them. And here is 1 here, 1 here. We don't write it, but we're supposed to know. So there will be 2 here, and we already got that here. We have done the power of power. So it kind of this is going to be multiplying this. We got that 3. There we get that. So this is going to multiply to that, and it's going to multiply to this also. So we get 4x minus 2. Since we have the same base, 3 here, 3 here, we can go ahead and equate the exponent. So therefore, 3 is equals to 4x minus 2. And we want to solve for x. So we have to bring this over here. So we add here 2, and we have to repeat the same thing here. So that here become 0. We get 5 is equals to 4x. So it's multiplying. One number multiply, that will give you 5. If we cannot have any number, but we are going to apply the inverse. So we're going to divide here by 4. And we'll repeat the same thing here. This 10 into 1. So we get 5 over 4 is equals to x. We can write it in the standard form with the x first, and then we got 5 over 4. And if we plug this back into the original equation, we realize that the left hand side is going to be equal to the right hand. Okay, so we have another one. Here we have been asked to solve for x. So we have 2 here. So let's break the 4 into 2 and see what will come out of it. So 2 times 2 give us 4. But remember there is x up here. So it's 2 to the power 2. So here we got power of power, so we'll multiply. Right now realize that there is of the same base, so we can equate the exponent. 2x must be equals to x plus 2. This is linear equation. We have to combine like terms. There is 2x here, there is 1x here, so we have to take the smaller to the bigger. Here we subtract x from here, and we repeat the same thing here, so that this becomes 0. Here we got 2, and here we got 1x, and that's the answer. So we have this 1/2 to the power x is equals to 4. We want to solve for x. Let's see what we can come out with. We see 2 here, so we can break down this into 2. So 4 is 2 squared. But this is half. But do we have a law of exponent that can help us to bring the 2 up? Yes, we do. So here it can be written as such. This is the same as that. Here become power of power. So multiply, so we got 2 is negative x equals to 2, 2. So now we have 2, 2, so we can equate the exponent. So therefore, negative x is equals to 2. And we are looking for x, not negative x. Now remember here is just negative, but we can put 1 in there if we want, if that will help us to understand it. There's nothing wrong with that. So 1, and then we need to get rid of that negative or negative 1 over there. So we divide here by negative 1. I'll have to repeat the same thing here. This goes away, it turns into 1, giving us negative 2 as an answer. Right, so we have so we see that we have a base 3 here, we have a base 9 here. Let's see if we can able to break this 9 into 3. So we'll repeat this. 9 is 3 squared, but remember we have this here, so let me cover it with a parenthesis. Some people call it bracket. Okay, so once we do that, we see that the base is the same, but here it kind of is a power. Here is a power of power, so we could have covered it with this if we want. So it's become power of power. So we will multiply that, and that will come right here. Now let's equate the powers. So here realize that we got radical equation or the surd equation, and we have done we have covered that lesson too. So we have to, the steps is that we have to isolate the radical or the surds, but here is already isolated. So we move on to the second step. We square both sides, so we're going to square that. So when we square, the square root goes away, leaving the radical behind. Here it's going to go on top here, so we're going to get that, and then this will go away. So here we got m. We are removing our parentheses, so 4 times m, and then 4 times negative 3 give us 12. We have to combine like terms. So for us to do easy work, we will get rid of this. So minus 4m, and we have to repeat the same thing here, minus 4m. Here is m. We can put 1 over there. There's nothing wrong with it, so that it will help us. So 1 minus 4, the negative is bigger, so our answer is going to be negative. We get negative 3. This turned into 0. Got 12 here. Here is multiplying, so we will divide to get rid of it. So we will divide here by negative 3, and we have to repeat the same thing here. This turn into 1. We get our m. That's what we are looking for. Negative cancel negative, and 12 divided by 3 is 4. Ta-da, we're done. So we have been given, and we want to solve it. We have to see if we can able to change the 36 in with respect to 6. And 6 times 6 give us 36, so we can say 6 squared. So here we have the same base, so we will equate the exponent. You realize that there is a square, so quadratic is coming in here. So this gives us opportunity to review our quadratic techniques. So we have to bring all of them in one side in order to solve it in the standard form. So we are bringing this one over here. That means we are subtracting. So here become negative. Okay. And now we want to solve a quadratic. We can put 1 here to bring more understanding. So we take our constant, the constant which is the negative 2, and then we look for 2 numbers that we multiply, that will give us 2 or negative 2 is only 1 and 2. By these two numbers, we have to be able to manipulate it that it will give us the coefficient of the x, which is 1. So we write our 2 and 1 here, and we have to manipulate it that we will get 1. So we can put negative 1 here. So negative 1 times 2 give us negative 2. And negative 1 added to 2 give us 1. And so it satisfies the constant and the coefficient of x. So we can use these two numbers here as a factor. So here we will write plus 2 and minus 1. But when we solve it, it's going to be opposite because it's going other side of it. So it's going to be equals to negative 2 or x is equals to 1. So we got two solutions for this. One of them might not be true. So what we have to do is that we have to plug it back to see which will make it true. So we have negative 2, so we plug negative 2 here. So negative 2 squared will give us 4 plus another negative 2. 4 minus 2, which is 2. And that's good. So because 6 squared plus 6 squared indeed is equals to 36. So here when x is equals to negative 2. Now let's see when x is equals to 1. So when x is equals to 1, we got 1. 1 squared is 1 plus 1, which is also 2. So here we got 2 and is equals to that. So all these two numbers are true. So the solution is x is equals to negative 2 and x is equals to negative 1. Alright, so we have this one here. So we see that we have 3 here, and then we see we can break the 81 with respect to 3, and it's going to be possible. So this 3 here, we have 1 over 3. 81 can be breaking to 3 to the power 4. We have the n here, so it's going to multiply. And here it's also going to be 3 to the power 4 times the 2 here. So we can rewrite it as 3 to the power 4n, all divided by 3 because of this equals to 3 to the power 8. Every number is to the power 1, and we have the same base dividing, so we can subtract. So here can be written as 4 to the power 4n minus 1 equals to 3 to the 8. Now we have 3 and 3 here. We can equate the base. We got 4n minus 1 equals to 8. We want to solve for n. So we will add here plus 1. We'll repeat the same thing here. We'll get 4 and equals to 9. It's multiplied, so we divide here by 4. Repeat the same thing here. Just 10 into 1 and n equals to 9 over 4. We can't simplify it any further, so that gives us the answer. We have a system of exponential equation, and we want to solve for x and y. So here we see 2 here, we see 8 here. Let's change the 8 with respect to the 2. 2 cubed will give us the 8, and this one is already in the same base. So here, since we have the same base, we can equate the powers, the exponent. So here we can say y is equals to 3x, and here y is equals to x plus 4. Okay. So here we have y is equals to 3x, and we have y is equals to x plus 4. So we have 1 and equation 2. We can solve it by system of equation. Since y is equals to 3x and y is equals to x plus 4, we can equate, we can say that implies that 3x must be equals to x plus 4. And we are solving for x, so we subtract x here and we subtract x here. This goes away. We got 2x is equals to 4. Divide here by 2, divide here by 2, then you get x is equals to 4 divided by 2 is 2. And now we can plug x equals to 2 into any of the equations. So let me take the simplest one. Y is equals to 3x. So here for us to get a y is 3 times 2, which is 6. So now x is equals to 2 and y is equals to 6. Let's look at this last question here. So we have been asked to solve for this exponential equation. We have 5 here and we have 21 here. We see we have 2 here. We cannot break 21 into 2, so let's see if we can do something about it. Let's get rid of this and see what will come out of it. So here we will subtract here 5. We have to repeat the same thing here. This goes away, leaving us with 2 to the power n minus 1 equals to 21 minus 5 give us 16. Okay, now we are making a headway. We know that for us to get 16 is add the 16 into 2 now, which is 2 times 2 times 2 times 2. So here, that means 2 to the power 4 is the same as 16. We have the same base. Now we have the same base. We can equate their exponent. So therefore, n minus 1 is equals to 4. And we are trying to solve for n, so we'll add 1 here. We'll add 1 here. This will go away. 10 into 0, and we get 5. And we are done. Please subscribe, like, and leave a comment. See you in the next video.